Mr. Lim has 6 children, and we are given that the probability of having a boy and a girl are equally likely, which is given by 0.5. Here we want to determine the probability that the last child is a boy, given that Mr. Lim has exactly one son. Let us call the first event A and the second event B. We first determine the probability of A. What are the elements that correspond to the case that the last child is a boy? Well, suppose here are the children of Mr. Lim, and we know that the last child must be a boy. There are no restrictions on the other children, so we have 2 possibilities for the first child, 2 possibilities for the second child, and so on. Therefore, altogether, we'll have 2 to the 5 different possibilities for the last child to be a boy. This number divided by the size of the sample space will give us the probability. The size of the sample space is 2 to the 6 because there are 2 possibilities for each child. So here the answer is half. Next, we determine the probability of the event B. When do we have exactly one son? Well, this only son can be the first child, or the second child, or the third child, and so on. Therefore, there are 6 possibilities altogether. For example, it could be the first child. Right, if first child is a boy, then we have boy, and all the other children are girls. The only son could be the second child. In this case, all the other children are girls, and so on. So altogether, there will be 6 possibilities. So the probability of B is 6 over the size of the sample space. This is 6 over 64. Next, we want to determine the probability of the intersection of A and B. What can we say about the element in the intersection of A and B? If we have only one son and the last child is a boy, then the only son must be the last child. The other children must be girl. So there's only one element in the intersection of A and B. In particular, that element is the configuration here. So this is the only element inside A and B. So the probability is just 1 over the size of the sample space. Having determined the probabilities for the event A, B, and the intersection A and B, we are now ready to compute the probability A given B as follows. We want the probability of A given B. This is equal to, by the definition of conditional probability, A intersection B divided by the probability of B. Using the values we obtained previously, we have 1 over 64 divided by 6 over 64, which is 1 over 6. Okay, in part B, we want to find the probability of having exactly one son, given that the last child is a boy. Well, in this case, the conditional probability is B given A. So as before, by definition, this is the probability of the intersection of B and A divided by the probability of A. Well, using the values we have previously, this is 1 over 64 divided by half. Which is equal to 2 over 64, that is 1 over 32.